Hello YouTube. So in this video we've got a teardown of this instrument here, but before that I just wanted to say thanks to all the new subscribers that have come along in the last couple of months. Unfortunately, from November, December, and what with Christmas and everything, I didn't have much time to make any videos. So this is the first one in quite a while. Anyway, back to this. This is it's titled Environmental Radiation Meter Type 6-70. It's made by a British company called Mini Instruments Ltd. So this is actually a Geiger counter which measures for measuring background radiation. You have a meter on this side giving you instant display, and there is also a timer function to allow you to do an integrated count over a period of time. I'm under the impression that this was used at the Trawsfynydd Nuclear Power Station located in North Wales. It's not really been confirmed, but I've got it on pretty good advice that was the case. Now that actually operated from 1959 to 1991. I'd say this. Well, I mean, you can see on the here there's a new battery installed. 83, so 1983. So this has obviously been in use for quite some time. Okay, so let's take a quick look around this and see what we can see. So it's constructed out of a steel box. There's a carrying handle on here, which has obviously seen better days, obviously showing its age. You've got the Geiger tube located on the top here. This is just a brown tube. There was a sticker on it here, but everything's worn off here apart from the last few digits of a serial number. On the top here you've got what is quite clearly a retrofitted clamp. Presumably it went the same way as this one and broken off. Now on the front panel we've got the meter, which is for the instant reading. So this is in micro Roentgens. We have two buttons here. One is readout and readout test. We've got two switches here, start and stop, and a rotary control to change the sampling time. And obviously we've got the connection out to the Geiger tube. On the back there is not a huge amount. We've got a fuse, 2 amp rated, a charging port, going by the instructions on the back here, and there is also a small meter here, presumably to show the battery voltage level, and it's indicated with the serial number 874. Oh, and there is also another port on here, which is like a 3.5mm headphone jack. I'm not sure what that does. We'll have to take a look inside and see what we think that might be. Now I have to confess I've actually been inside this already. I've actually had a little bit of a play around with it because I wanted to see whether it's working or not. So I've sort of familiarised myself with the insides of it. So I'll just open it up now and I will show you the inside. So the back panel here just comes off with these 6 screws on the back. And we have a set of batteries here, which have been sandwiched by this metal plate here, secured with these 4 bolts. We've got a small circuit board here, the meter that we saw on the back, and power connections. Now, you might well have noticed already there's this writing here which says modified by IMD October 83. So I'm not sure what's actually gone on here, but I would just, given that there's these connector blocks on the battery terminals, I wonder whether the original battery has been swapped out for these cells in here. Maybe the original battery was a bit of an odd type, or it was just cheaper and easier to retrofit these batteries in instead. Right, I have actually already checked these batteries and they are absolutely completely flat, so I'm going to just take off this now, get rid of this big heavy weight off this back panel, and that should make it a little bit easier to go a bit further into the inside. Right, so I've just taken out the batteries here. You can see these look like D cells, nickel cadmium. Okay, well, two of them are D cells. The other two are a slightly different size. They certainly look like they're dated from... Oh, wires dropping off. These certainly look like they're dated from the early 80s. We've got here 1.2 volt, 7 amp hour, which is a fairly hefty battery for its time. Right, so I've got the front and back panel out here on the bench, so we can take a better look at what we're actually dealing with. What we've got here is a board here, and there's a sandwich of two boards here. Now, from what I've been able to determine, this is quite clearly the logic board, which creates the 8-segment display on here, and has also the timing options. There is no, or the only link between this board and this one is this 2-wire connection. So this is quite clearly the driver for the Geiger Muller tube and the driver for the meter, but it obviously has a separate output to run through to this logic section here, which looks like it might just be a timer and a counter. Now this board up here looks to be a power supply board. Now, whether this has something to do with the modified, I'm not entirely sure. The batteries that were actually loaded in this, there was 4 at 1.2, so that's 4.8 volts. Or 5, we'll call it 5 volts. Now the logic board will clearly run on 5 volts, but the voltages on here are actually more like 10 to 12. So I wonder whether this might be retrofitted on. If somebody swapped out the battery and used these NiCad cells, they might have needed to boost the 5 volt up to run this board here. I'm not entirely sure on that. It all depends what the original battery was. Okay, we've got the logic section here. So we've got a whole load of 7.4 series logic. We've got this device here which looks very much like a big crystal oscillator. We've got this small little daughter board here. Now that doesn't look retrofitted. I'm not entirely sure why it's been done like that, but it looks fairly intentional, to be honest. Maybe they used this board in other things, and it needed something extra in this situation. I don't know. So if we look at the side here, we can see just in here we have the 8-segment displays. Those look pretty old school. There's another whole load of got the 2 switches and the rotary switch down here. So this board here is the driver for the Geiger Muller tube. So this will have a high voltage power supply on. I would imagine that the 2 transformers here form part of that power supply circuit, and this will also drive the panel meter on the front as well. Now this also provides this output to the logic board. So as the pulses come from the Geiger Muller tube, they're just passed through onto the what is just the counter board. These 2 connections here run through to a BNC connector on the front panel, which then runs off to the probe. And we've also got this this other connection here, which looks like a 3.5mm headphone jack. We've got 3 wires coming off that. My only thoughts about what that would be is some kind of direct output from the Geiger tube or something. Okay, so if we just flip this around so we can have a look at this this board here, there's 2 pairs of connections. One goes to the driver board for the actual Geiger tube, and the other one comes from the logic board. Now if you can just see here, the connections running to this are the same as the power that goes to the logic board, so these are directly from the battery. So this is boosting the battery from its nominal 4.8 volts up to I measured about sort of 10 to 12 volts on the output of this. So it probably runs on 12 volts or something. Okay, if we put that aside and have a look at the actual probe itself. Now I would imagine this is a Geiger Muller tube. I can't think of any reason why it wouldn't be. It's just a single BNC connection on the end. There used to be a sticker there, but has long since worn off. I presume that's the serial number, or was. There's no way into this. There is a slight ring to it, so it does seem like it should be a Geiger Muller tube. If it is, it's very, very big. I mean, normally Geiger tubes are sort of this sort of size, or even many times smaller, but they do come this size depending on the application. So for those of you who don't know what a Geiger Muller tube is, what they are is a fairly simple device for measuring ionizing radiation. They're essentially a low pressure gas separated by 2 electrodes. You then apply a voltage across the 2 electrodes, and as ionizing radiation hits the tube, or whatever shape it is, it doesn't actually have to be a tube, it causes an avalanche effect inside the within the gas, which causes a measurable output on the power supply. So it basically creates little pulses as particles interact with the tube, and this is then measured and then converted into things like Roentgens or sieverts, what have you, which is obviously quite different to counts. Counts per second are the actual pulses as they come out of the tube. So if you have 5 counts, that is actually 5 detections within a tube. Now how that equates to radiation as it affects humans and other things is completely different, which is why there's so many different types of and ways of measuring radiation. I suggest you go and read the wiki pages on that to get a better idea on that, because it's far too complex a subject for me to talk about here. Now, when I first saw this, I was actually quite surprised at the size of this. You don't often see Geiger Muller tubes of this size. Obviously, the tube itself is contained within this, which appears to be, it's almost like Bakelite, but it seems more like a resin impregnated paper kind of thing. It's quite a substantial substantial unit. Now, normally this is a Geiger Muller tube. This is an SBM 20, which is a very, very common Russian-made Geiger tube. So if you compare that to the size of this, you can obviously tell that this tube is going to be a whole lot more sensitive than this one. Now, the actual drive voltage of these does vary quite a bit depending on the actual tube. One of these SBM 20s runs at well, just a bit under 400 volts. The bigger tubes tend to run with higher voltage, and some can actually run up to 900 or 1000 volts, depending on the internal construction and what gases they use inside. Right, I've just got this connected up now to my bench power supply. I'm feeding 5 volts into where the batteries were connected to. So I'm just going to try and run through and describe how this might work. Now, it's actually a little bit difficult because it doesn't actually work. It doesn't seem to work properly anyway. So if I just turn it on. Now, when you turn this on, you tend to get random digits on here. So I think clearly there's a fault on the on that logic board that we looked at earlier. Maybe some investigation might be able to fix it, but I think typically you would install this unit into wherever you want to monitor the radiation. You'd then select the time interval that you want to sample over. On this, you've got infinity and 10 seconds to 1000 seconds. So you'd, if you needed to sample for 50 seconds, you turn the knob to 50 and then press the start button, and it will then count up the pulses from the Geiger tube, and then display you a final reading at the end of the selected time interval. Now, obviously, you saw the display go off there. You can actually bring that back if you press the readout button, and you can just stop it at any time just with the stop button. So there's no detail on what this actually is, whether this is counts or whether it's Roentgens or whether it's some other type of reading. It just doesn't say. Now, as I just said, I don't think the logic side, this display, is working correctly, and unfortunately, although there is actually a reading on this this meter here showing what you would expect to be background radiation, I don't believe that this tube is actually working. I do actually have a radioactive source here, which is a small piece of Fiesta ware pottery. This contains uranium oxide to give it the colour. Now, this is actually a pretty good source, and it's pretty strong. If I turn on my my other Geiger counter, you can see there it's picking up the background radiation. And if I put this near, you can see a fairly healthy reading there. The counts per minute will eventually go above about 1000 or so. So you'd expect, when I put this against the Geiger tube, that you'd see some pretty significant readings on here, but obviously it doesn't. It's just no response at all. So I think the tube that's inside this is has reached the end of its life. Right, just to verify what I think about this tube here, I've got my mighty ohm Geiger counter here. Again, if I put my source up against this, you can see that it's a pretty clear response. So what I'm going to do is connect this up to this tube and see how it reacts. Right, so I've got this this connected up here, just with a couple of little adapters. I've got two clips on the connections where the old tube used to be. So I've got the voltage turned right down to as far as it goes down. So if I switch this on, right, start increasing the voltage on here. I do get an output, which does kind of sound like very much like background radiation, but unfortunately again there is no response at all from my Fiestaware. I mean, a tube of this size should be going absolutely nuts with this sample. Okay, I think that pretty much wraps it up for this. I've just checked some of the date codes on these, on some of the devices in here, and it appears to date from about 1974, which makes it about as old as I am. It's a shame that this doesn't seem to work. I was kind of hoping this would have been a nice sensitive Geiger Muller tube that I could have used myself, but sadly not. I think given that this clearly is broken or not working, I'm probably going to do a teardown on this. It's actually completely sealed inside here. There's no discernible way to get inside it, so it'll probably have to be a fairly destructive test, a destructive teardown, I should say. So I'll save that one for a future video. That could be interesting. Right, thanks everybody for watching. If you like this, hit the like button, that's cool. If you've got any comments or suggestions on things to try before I take a hacksaw to this, then let me know in the comments. Okay, I'll see you on the next video.